Dear physics aspirants, right now I have the Gauss law. This subtopic will come under electric charges and fields of physics plus 2 level. Here you will see the flux through a sphere enclosing a point charge q at its center. You will see the figure, and figure will provide you the lots of information regarding the Gauss's law. Gauss law is a simple application of the notion of electric flux based on the electric flux. Here is the content, and you will see here as a simple application of the notion of electric flux. Let us consider the total flux through a sphere of radius r, which encloses point charge q at its center. Divide the sphere into small area elements as shown in figure 1.25. You will see here the figure 1.25. Radius r is here. The flux through an area elements is S is here, and the flux is magnetic flux, and is equal to E into S is equal to Q by 4 pi E0 R square into R, and the vectors and scalar. When you study, then you will see this arrow marks here, and into S, where we have used Coulomb's law for the electric field due to a single charge q. Coulomb's law will provide you the lots of information regarding when you study the Gauss law. The unit vector r, here is the r is the vector, is along the radius vector from the center to the area element. Now, since the normal to a sphere at every point is along the radius vector at that point, the area element S and r vector have the same direction. Therefore, you will see the magnetic flux, and here the q by 4 pi E0 r square into S, since the magnitude of the unit vector is 1. The total flux through the sphere is obtained by adding up flux through all the different area elements. Here is the figure will provide you the lots of information regarding what I am asking. I am asking regarding the electric charges and fields, and when you study this chapter, then Gauss law will be very important for your understanding. In this topic, you will see the 1.26 figure, calculation of the flux of uniform electric field through the surface of a cylinder. You will see the cylinder, and this figure will provide you the uniform electric field, flux of uniform electric field, and here is the flux, and E summation all S and Q by 4 pi. You will see here the equation, since each area element of a sphere has its same distance r from the charge, and equation is flux is here is equal to what will be now as the total area of the sphere equal 4 pi square. Thus flux is here, and you will see total area into 4 pi r square, and q by e. You will see here in equation 1.30 is a simple equation. 1.30 is equation 1.30 is a simple illustration of a general result of electrostatics called Gauss law. We state Gauss law without proof. Electric flux through a closed surface S is equal to Q by 0. Q is total charge enclosed by S. 1.31. The law implies that the total electric flux through a closed surface 0 if no charge is enclosed by the surface. We can see the explicitly in the simple equation situation in figure 1.26. Here the electric field is uniform, and we are considering a closed cylindrical surface with an axial axis parallel to the uniform field E. The total flux through the surface is flux 1, 2 and 3, where 1, 2 represent the flux through the surface H1 and 2 of circular cross section of the cylinder, and flux 3 is flux through the curved cylinder part of the closed surface. Here you will see now the normal to the surface 3 at every point is perpendicular to E, so by definition of flux is 0. Further, the outward Normal to 2 is along E, while the outward normal is 1 is opposite of E. Therefore flux is here, where S is the area of circular cross section. Thus the total flux is 0 as expected by Gauss law. Thus wherever you find that the net electric flux through a closed surface is 0, we conclude that the total charge content in the closed surface is 0. The great significance of Gauss law equation 1.31 is that is true in general and not only for the simple cases we have considered above. Let us note some important points regarding this law. Kindly memorize these facts. Gauss law is true for any closed surface, no matter what its shape or size. The term Q on the right side of Gauss law, equation 1.31, includes the sum of all charges. So summation symbols you will see here. You have seen summation, and you will see here the charges enclosed by the surface. The charges may be located anywhere inside the surface. In the situation when the surface is so chosen that there are some charges inside this and some outside the electric field whose flux appears on the left side of equation 1.31 is due to all the charges both inside and outside S. The term Q is on the right side of Gauss law, however represents only the total charge inside S. Before you're going to study the Gauss law, Coulomb law should be studied. The surface what we chose for the application of Gauss law is called the Gaussian surface. The surface is known as the Gaussian surface. You may choose any Gaussian surface and apply Gauss law where, but take care not to let the Gaussian surface pass through any discrete charge. This is because electric field due to a system of discrete charge is not well defined at the location of any charge. As you go close to the charge, the field grows without any bound. However, the Gaussian surface can pass through a continuous charge distribution. Gauss law is often useful towards some much easier calculations of the electrostatic field and when the system has some symmetry. This is facilitated by the choice of the suitable Gaussian surface. Finally, Gauss law is based on the inverse square dependence on distance contained in the Coulomb's law. So Coulomb's law should be initiated. Any violation to Gauss law will indicate departure from the inverse square law. Here is the example 1.11 will provide you the information what I'm asking, that the flux, total flux and electric field component, and here is the solutions. Solution is here. With the help of this answer you can understand. Another is there, and you will see here is the Gaussian laws, and example 1.2 is also here. Kindly retry again and again, then you will see the Gauss law, because in examination of the medical and engineering it will be very important, and for the academic examinations also. So in the point of view of the competition, you should initiate it. We will in the next session with a lot more. Till then, thank you. Thanks for watching the video. Thank you.